Hello, we will be discussing the role of computer science in global sea level rise research.
In particular, how computer science is part with global climate modeling.
Computer science plays an interesting role in examining sea level rise, as it is a strong tool to synthesize data from data theories and laws from other fields into a combined model of the climate. The physical laws governing climate operate on far too fine a scale and are far too complex to directly apply into a model. One large example of this is the Navier-Stokes partial differential equations that model the fluid dynamics necessary to model the atmosphere. They are far too complex to solve. They are almost unsolvable, and they're very difficult to directly approximate. Instead, climate models work by dividing the Earth's atmosphere, surface, and oceans into a 3D grid and approximating the behavior of each cell in that grid. Each cell is approximated over a time step, which is about 30 simulated minutes long for modern models. Then cells take the state of every neighboring cell before the process is repeated. Having more cells or cells with shorter time steps can give a more accurate simulation.
The earliest models were developed in the 1970s. These were initially very simple models that would look at atmospherics or oceanics separately, but over time, coupled models were developed that bring in more and more factors. Modern models bring in truly astounding number of factors, looking at volcanics, dynamic plant growth, chemical changes in the atmosphere over time, sea and snow ice, and many other elements. Similarly to the difficulties of simulating the atmosphere accurately with the Navier-Stokes, these systems are not simulated in full, rather they are parameterized for each cell. These parameterizations are only approximations of the phenomena, and they do need to be tuned for each model. However, by having each cell function independently based on parameterizations, these models can be run efficiently on parallelizable supercomputing hardware. As seen here, in this model, global scale coupled climate models check for all different type of elements, including marine ecosystems, ocean, atmospheric chemistry, dust, sea spray, interactive vegetation, and so on.
As every model works off of approximations and not absolute definitive simulations, they become objects of study in their own right, and it's important to be able to evaluate their successes and relative performances so as to improve them. These can be used to test different scenarios where humans behave differently. This can be useful for policy decisions and the like. The most basic tests usually applied to these models are called hindcasts, where the models are run on past data to measure the performance. However, there are many more types of analyses and comparisons. The coupled model intercomparison project plays an important role here, and it is so central that a lot of important sources draw their information from this project. The coupled model intercomparison project brings together research groups from across the world to run standardized tests. Some of these are control tests that ensure the models don't predict a changing environment on unchanging inputs. They also have a sudden CO2 change test to measure the modeled responsiveness of Earth to CO2. And then there's some special simulations as well that model things like proposed geoengineering solutions. This is a lot of work to evaluate and improve these models, but it is effective. First, these models are highly accurate to begin with, as can be seen in this graph. And second, they are getting better over time. Around a little over 15 years ago, these models required flux corrections as they were predicting, which were based off of observations and were pushing them closer to the correct answer. But now new models hardly need those at all and can basically do their predictions just off of a starting state and the condition they're testing. This makes computer modeling a very effective tool for examining the climate and consequently sea level rise.